Hey everyone, welcome back to the channel Code with AKJ. Today is day 16 of solving LeetCode Sanctify challenge. Today's problem is max consecutive ones 3 from sliding window technique. So the question says here given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So given here nums array and k value 2, which means we need to flip at most 2 zeros in order to maximize our number of consecutive ones in this array. And you can observe here bolded numbers are the numbers which are flipped from 0 to 1, and the underlined numbers are the longest subarray with maximum number of consecutive ones. So here in the given example 1, the length of the longest subarray with maximum number of consecutive ones is 6. Given example 2, here we need to flip at most 3 zeros in the given binary array. So as you can see in the given example, the bolded numbers are the numbers which are flipped from 0 to 1, and the underlined subarray is the longest subarray with maximum number of consecutive ones. So in this given example, the length here would be 10. So the problem is simple but yet tricky. So given a binary array nums and an integer k, we want to find the maximum number of consecutive ones in the array if we can flip at most k zeros. So let's start with our brute force approach. In our brute force approach, we'll examine every subarray, we'll count the zeros and check if flipping k zeros gives us a valid subarray with maximum ones. So in our brute force approach, since we examine every subarray, we use two for loops. There would be a outer loop which starts from 0 to n. There would be an inner loop which starts from I to n. So these are the few subarrays written here. So in our brute force approach, we'll generate all these subarrays, we'll count the number of zeros, and if at any point the number of zeros exceeds the k value, we'll stop there and we'll update our maximum length. So here in this case, the maximum length would be 5. So this would be our first iteration where I starts from 0 and j starts from I to n. In the following iteration where the I starts from this particular point and j starts from I to n, we'll get the longest subarray where the number of zeros would be equal to k and the length here would be maximum, which is 6. And the subarray where we flip at most k zeros and has the longest length would be 0, 1, 1, 1, 1 and 0. So if we flip these two zeros, we'll get a subarray 1, 1, 1, 1, 1, 1. So the length of this given subarray would be 6. And for this example, the maximum length with at most k zeros flipped, which would give us maximum number of consecutive ones, would be 6. For this brute force approach, the time complexity would be O of n square, as we are using two for loops to examine every subarray, and space complexity would be O of 1. So let's quickly look at the code and let's submit. So here's the brute force approach code. Here I have taken the size of an array. I have also taken a variable max length, which would be initially 0. I have taken two for loops, one outer loop which would iterate from 0 to n, and one another inner loop which starts from I to n. Here I have taken 0 count, which would count the number of zeros for every subarray, and will count the number of zeros in that particular subarray, and if at any point 0 count becomes greater than k, we'll stop there, and for every value we check, we'll update our max length with the current subarray length. And finally, after finishing our two for loops, we'll get our max length. So let's quickly run this code. So let's submit. As you can see, this approach of solving this problem gives us time limit exceeded because of its time complexity, which is O of n square. So let's quickly optimize this approach and bring down the time complexity from O of n square to O of n. So in our optimal approach, we'll try to use sliding window technique here, since they are asking us to maintain a subarray where we can flip at most k zeros. So the k value gives us an idea to maintain a window of the subarray where we can flip at most k zeros. So in this way, we can decide that we can use sliding window technique here. So we'll maintain a window of consecutive ones by allowing up to k zeros within the window, and if the number of zeros exceeds k value, we'll shrink the window from the left. So this is how our optimal approach works. We'll maintain a window with maximum consecutive ones, and we'll also allow at most k zeros in this given window. If in any case the value of 0 exceeds our k value, we'll try to shrink this window from our left side. So let's move on to the code first, and then we'll try to dry run with this given example. So here's the code for our optimal approach. Here I have taken the left value and the max length value, and the 0 count value. So here I have iterated over this array with a right pointer till the size of the nums array, and we'll check if the current value is a 0. So we'll increment our 0 count variable, and we'll also update our max length value with our current subarray length. Since we are maintaining a window here, we'll check the number of zeros which we allow in our window, which is at most k zeros. So if in any case the 0 count value exceeds our k value, we will try to shrink the window from the left side. So we'll check if the nums of left is 0, we'll decrement our 0 count value, and we'll move our left pointer one step ahead. So finally we'll get our max length value, and we'll return max length after finishing our iteration over this given array. So let's run this code. So okay, so let's submit. As you can see, this approach gives us successful submission. So sliding window approach here avoids unnecessary computations, achieving an efficient O of n time complexity. And here the space complexity would be O of 1. So let's quickly dry run this approach with this given example, and let's finally analyze the time complexity and space complexity of both approaches we have discussed. So let's quickly dry run our optimal approach with this given example. Here I've taken 0 count variable, left variable, right variable, which would be initially 0, and max length variable, which is also initially 0. Here also maintain a window, and let's start with a right pointer which starts from index 0. So the current element here is 1. So 0 count variables remains 0 as no zeros in this window, and window size here would be right minus left plus 1, which is 0 minus 0 plus 1, that is 1. So the window size here would be 1. So we'll update our maximum length from 0 to 1. And next we'll move our right pointer to the next index. Here the current number value is 1. So 0 count variable remains 0, and the window size gets updated from 1 minus 0 plus 1, that is 2. So the window size is 2, and the max length value updates from 1 to 2. We'll move our right pointer to the next index. Again the current value is 1. This remains 0 as well, and the window size changes from 2 minus 0 plus 1, that is 3, and we'll also update our max length value from 2 to 3. We'll again move our right pointer to next index. Here the current value is 0. Now we'll change our 0 count variable from 0 to 1, and we'll also update our window size, that is 3 minus 0 plus 1, that is 4, and we'll also update our max length, that is 4. So let's again move our right index to the next index value. So here the next index value is 0. We'll increment our 0 count value from 1 to 2, and we'll also update our window size, that is 4 minus 0 plus 1, that is 5, and we'll also update our max length from 4 to 5. And for the next iteration, we'll move our right index to the next index. Here the current value is 0, so we'll increment our 0 count from 0 to 3. Here the condition violates, that is 0 count is greater than k. So here we'll shrink the window from the left. So nums of 0, that is 1. So there would be no change to 0 count, and we'll increment the left pointer from 0 to 1, and the window size remains 5 itself, that is 5 minus 1 plus 1, that is 5, and max length remains same. So we'll continue to shrink our window until or unless our window contains at most k zeros, that is 2 zeros. So the left pointer moves from index 0 to index 4, and the current window contains 0, 0, 1, and we'll move our right index to the next value. So after moving our left pointer from index 0 to 4, our current window contains 0, 0, 1, and the window size becomes 3, that is 6 minus 4 plus 1, and the max length remains same, that is 5. And we'll move our right pointer to the next index, which contains the value 1. So we'll include that into our window, and the window size changes from 3 to 4, and the max length remains 5. And again we'll move our right pointer to the next index, which contains value 1. So we'll include that to our window, and here the window size becomes 5, and the max length remains 5. And again moving right pointer to the next index value, which contains value 1. So here the window size becomes 6 with k zeros. So the window size becomes 6 and we'll update our max length from 5 to 6. And finally, after including our last index value which has value 0, so here the condition again violates, which says the number of zeros are greater than k. So we'll try to shrink this window from the left side. So here the left side value is 0, so we'll decrement our 0 count, and in this way we'll get our longest subarray with consecutive ones with at most k zeros, which can be flipped to make this array with maximum consecutive ones. So in this way, after finishing our loop, we'll get our max length, that is 6. So the time complexity of this approach would be O of n, as we are iterating over this array only once, and space complexity here would be O of 1, as we are not using any external data structure. So let's quickly analyze the time complexity and space complexity of both the approaches. So the brute force approach we have used takes O of n square time complexity and O of 1 space complexity, whereas our optimal approach takes O of n time complexity and O of 1 time complexity. And that's it, guys. We have solved max consecutive ones 3 with a brute force and an optimal approach. So if you found this video helpful, make sure to hit the like button, subscribe for more coding tutorials, and share it with your fellow coders. And don't forget to practice this problem on LeetCode. Thank you.